Let's solve this geometry problem carefully and keep our attention on the one idea that makes the calculation much easier. We have an equilateral triangle XYZ placed inside a circle, and the center of the circle is point M. We are told that M lies on side YZ. Each side of the equilateral triangle has length 15 units. Also, the distance from Y to M is 6 units, and the distance from M to Z is 9 units. We need to find the exact area of the circle. Now, before calculating anything, let's ask ourselves, what information the area formula actually requires? Then the area of a circle is pi multiplied by the radius squared. So, instead of spending time finding the radius itself, our smarter target is the square of the radius. Since M is the center of the circle and X lies on the circle, the segment XM is a radius of the circle. Let's call that radius R. Therefore, what we really want to determine is R squared. Notice how useful this is. If we can find R squared directly, then we can immediately substitute it into the circle area formula without ever taking a square root. Now, let's use the information about the triangle. Triangle XYZ is equilateral, which means all three of its sides are equal. Since each side has length 15 units, we know that XY equals 15, YZ equals 15, and XZ equals 15. But an equilateral triangle gives us another very important fact. All three interior angles are equal, and the angles of a triangle add up to 180 degrees. So each angle must be 180 divided by 3, which is 60 degrees. Therefore, angle XYZ is 60 degrees, and angle XZY is also 60 degrees. Now, pay close attention to the position of M. Point M lies on side YZ, so the ray from Y through M follows the same straight line as side YZ. That means the angle between X, Y, and YM is the same 60-degree angle we already know from the equilateral triangle. Therefore, angle XYM equals 60 degrees. At this point, we can focus on the smaller triangle XYM. In this triangle, we know that XY is 15 units, YM is 6 units, and the included angle XYM is 60 degrees. The remaining side XM is our radius R, so we have a triangle where two sides in the included angle are known, and we want the third side. This is exactly when the law of cosines becomes useful. The law of cosines tells us that the square of the side opposite a given angle equals the square of one known side plus the square of the other known side minus 2, multiplied by those two side lengths, multiplied by the cosine of the included angle. So, applying it to triangle XYM, the side opposite the 60-degree angle is XM, which is ER. Therefore, R squared equals 15 squared plus 6 squared minus 2 multiplied by 15, multiplied by 6, multiplied by the cosine of 60 degrees. Let's simplify this carefully, one part at a time. 15 squared means 15 multiplied by 15, which gives 225. 6 squared means 6 multiplied by 6, which gives 36. So our equation becomes R squared equals 225 plus 36 minus 2, multiplied by 15, multiplied by 6, multiplied by the cosine of 60 degrees. Now let's simplify the multiplication in the last term. 2 multiplied by 15 gives 30, and 30 multiplied by 6 gives 180. Therefore, we have R squared equals 225 plus 36 minus 180, multiplied by the cosine of 60 degrees. Next, we use the standard trigonometric value that the cosine of 60 degrees equals 1/2. So we substitute 1/2 for the cosine of 60 degrees. This gives us r squared equals 225 plus 36 minus 180 multiplied by 1/2. Now, half of 180 is 90, so the equation becomes r squared equals 225 plus 36 minus 90. Before combining everything, notice that 225 plus 36 gives 261. Therefore, r squared equals 261 minus 90. Subtracting 90 from 261 gives r squared equals 171. Excellent. We have found exactly the quantity we were looking for. The squared radius is 171. We could technically say that the radius itself is the square root of 171. But there is no reason to do that because the area formula already requires the radius squared. However, let's not rush to the final answer yet. We have another part of the triangle that allows us to check our result independently, and this is a very useful habit in geometry. If the same unknown can be calculated in two different ways, getting the same answer gives us strong evidence that our work is correct. So now let's consider triangle XZM. From the original equilateral triangle, we know that XZ is 15 units. We are also given that MZ is 9 units, and because angle XZY in the equilateral triangle is 60 degrees, and M lies on the same straight line as ZY, the angle between XZ and ZM is also 60 degrees. Therefore, angle XZM equals 60 degrees. Again, we have two known sides and the included angle, so the law of Cosines is the natural tool. The side opposite the 60-degree angle is XM, which is our radius r. Therefore, r squared equals 15 squared plus 9 squared minus 2 multiplied by 15 multiplied by 9 multiplied by the cosine of 60 degrees. Now let's simplify this carefully. 15 squared is 225 and 9 squared is 81. So we get r squared equals 225 plus 81 minus 2 multiplied by 15 multiplied by 9 multiplied by the cosine of 60 degrees. Next, 2 multiplied by 15 gives 30, and 30 multiplied by 9 gives 270. Therefore, r squared equals 225 plus 81 minus 270 multiplied by the cosine of 60 degrees. Again, the cosine of 60 degrees is 1/2, so we substitute 1/2. That gives r squared equals 225 plus 81 minus 270 multiplied by 1/2. Half of 270 is 135. So now we have r squared equals 225 plus 81 minus 135. Add the first two numbers, and 225 plus 81 gives 306. Therefore, r squared equals 306 minus 135. Subtracting gives r squared equals 171. Perfect. We have arrived at exactly the same value as before. From triangle XYM, we got 171, and from triangle XZM, we also got 171. That agreement confirms that our calculation is consistent. If you found this double check useful, this is a great point to like the video, subscribe to the channel, and comment with the value you got before I revealed the answer. Now, we can finish the problem. The area of a circle is pi multiplied by the radius squared. We already know that r squared equals 171, so there is no need to calculate r itself. We simply substitute 171 into the area formula. Therefore, the area equals pi multiplied by 171. We can write that exact result as 171 pi square units. That is the exact area. If we also want a decimal approximation, we can use pi approximately equal to 3.14159. So the area is approximately 171 multiplied by 3.14159. Carrying out that multiplication gives approximately 537.21 square units. So our final result is that the exact area of the circle is 171 pi square units, and the approximate area is 537.21 square units. And notice the main trick one more time. We never actually needed to calculate the radius itself. The area formula uses the radius squared, and the law of cosines gave us the radius squared directly. That is what makes this solution efficient. When you see a geometry problem where the final formula requires a squared quantity, always ask yourself whether you can calculate that squared quantity directly instead of finding the quantity first and then squaring it